Kirti, Kirti, Pikesh, Prajwal Gowda, Prajwal Gowda, Ramesh, Ratan, Rohan, Rutik,
Yes, sir.
okay, Rutvik, Sadashiv, Sagar, Sai Prakash,
Present, sir.
right, Samir Ahmad, Samir Ahmad, Samir Ahmad is present, Sania,
Present, sir.
okay, Sanjay, Sankalp, Sanket, Shiraj,
Present, sir.
right, Shivnanda Natikar, Shraddha, Shraddha,
Present,
okay, Shubham,
present, sir.
okay, Sumit, Suraya Banu, Tejas,
Present, sir.
okay, Vivek, Yamanappa, Gavkar Rajat Ramchandra, Manjunath,
Present, sir.
right, Pratmesh, Joslino, Soham, Atia, okay. Anybody else join?
Sir,
Roll
Sankal.
number 3.
Roll number 3, okay. Anybody else?
Sir, 23.
23, okay. Anybody else?
Sir, 20.
I have marked 20. I have marked. Okay. So we're discussing the assignment questions. Next question is question number 10. Question number 10, that is determine the voltage gain Z in Z naught of common base configuration using AC equivalent circuit with RE model. Okay, question number 10 it is. So let us derive the equations for the common base configuration, voltage gain, input impedance, output impedance considering the AC equivalent RE model for the common base configuration. This is the common base configuration circuit. I hope everybody are able to see here. Everybody are able to see?
Yes, sir.
Okay. This is a common base configuration in which the base terminal is common between the input section and the output section. RE resistance is present, emitter resistance. VEE is the supply voltage to the emitter terminal. RC is the collector resistance. VCC is the collector terminal voltage. Then VI is input voltage, II is input current, IE is the emitter current, IC is collector current, V0 is the output voltage, ZI and Z0 are the input and output impedances. Now for this common base configuration, the AC equivalent circuit is drawn, right? We know how to draw the AC equivalent circuit, right? This is our RE model for the AC equivalent circuit. RE model, how to draw the RE model? We have to short the capacitors. We have to short the capacitors, and if there are any DC voltage sources, we have to ground them or we have to make them zero. Is it not? So if we make them zero, then here RE will be connected between emitter to ground, emitter to ground. Okay. So here RE comes between emitter to ground or emitter to base terminal because it is common base configuration, emitter to base terminal. Then we have on the other side, that is RC resistance, okay. Okay, RC resistance is there on the other side across the output. Then this is RE, that is here emitter to base. For common base configuration, it is RE resistance is present. Okay, RE. Here we have the RE. It is RE model, so it is RE will be coming here, right? That is the AC resistance, AC resistance of the transistor or the emitter base forward biased junction of the transistor or of the PN junction of the transistor or of the diode. Okay, AC resistance small RE. Then next is for common emitter configuration and common collector configuration, we have beta IB. Remember, for common base configuration, we have alpha IE. Okay. For a common emitter and common collector, we are having beta IB. For common base configuration, it is alpha IE. Alpha IE. Okay. It is current gain is given by alpha is equal to IC upon IE for the common base configuration. Whereas for common emitter and common collector configuration, it is IC is equal to beta into IB. Okay. So here IC is equal to alpha IE. IC is the current. If you see here, IC is moving out from the collector terminal. So here also it is moving out from the collector terminal. It is alpha into IE. Right. This is VI, V naught, II, IE current into emitter terminal. IC, then I naught is the output current. Zi and Z naught are the input and output impedances. This is the RE model. Now in this RE model, the output resistance R naught is very high. It is in terms of mega ohms. Hence, it is ignored, which is at the output side. Because of large value of R naught, the value of R naught is ignored. Okay, because for simplicity purpose, the value of R naught, which is very high, is ignored. It is not considered at the output side. Output resistance R naught. Let us find the input impedance. From the RE model, we will find the Zi, which is nothing but parallel combination of capital RE and small re. Zi is the input impedance, which is parallel combination of capital RE and small re. Okay, it is across the VI terminals, across the voltage terminals. It is RE, capital RE parallel, small re. That is Zi is given by VI by II, input voltage by input current, VI by II, that is capital RE parallel, small re. Now, small re is very, very less than capital RE, or capital RE is very, very larger than small re. Therefore, if we take the parallel combination of large resistance with small resistance, we know that the equivalent resistance will be the smaller value. Therefore, Zi will be equal to small re approximately. Then output impedance Z naught. If we want to find output impedance, remember we have to turn off the active sources. That is, we have to set Vi equal to 0. We have to make Vi equal to 0. So whenever you are finding the output impedance for all these circuits, right, AC analysis, AC modeling, we have to make the input voltage 0 for finding the output impedance. So if we make Vi equal to 0 here, if we make Vi equal to 0, II will be 0, input current will be 0, and if II is 0, IE will also be 0. Okay, main current II is equal to 0, therefore IE is also 0. If IE is 0, then alpha IE will also be 0. Alpha IE will also be 0. That means this alpha IE will be the open circuit. It will become open circuit. Okay. Alpha IE will be 0. It is current source is nothing but it's open circuit, equivalent circuit. So it is open circuit here. That is across here alpha IE is open circuit. It is 0. Then across this RC resistance is present. RC resistance is present. Okay. This is the RC resistance. Fine. Therefore, what will be Z naught here, students? Across the output terminals here, if you look from this side, across the output, what will be Z naught? Z naught will be equal to RC. Z naught is equal to RC, only RC. Right. Next is voltage gain. So if we look into the above RE model, V naught is given by RE model. V naught is equal to minus I naught into RC. If we look into this circuit here, V naught is minus I naught into RC. Okay, minus I naught into RC. Because current entering positive, current leaving negative, positive to negative minus I naught RC, positive to negative minus V naught equal to 0, or V naught is equal to minus I naught RC. V naught is equal to minus I naught RC, or that is minus of what is IC? IC is equal to minus I naught. Correct? IC is equal to minus I naught. The direction of IC and I naught are opposite. Therefore, IC is equal to minus I naught. IC is equal to minus I naught. Substitute that IC is equal to minus I naught, or I naught is equal to minus IC. Therefore, this will be minus into minus plus IC RC. Similarly, find VI. If you want to find voltage gain, we have to know V naught first and then VI. Then take the ratio of V naught by VI, which will give the voltage gain. Next is VI. What is VI given by? VI is IE, which is across voltage parallel. Therefore, VI will be IE into RE. IE into RE. Okay, across voltage is IE current into this resistance RE. Okay, small RE. That is VI is equal to IE into small RE. IC is equal to alpha times IE, or alpha is IC by IE. Alpha is IC by IE, or IC is equal to alpha into IE. Therefore, here we have to substitute for IE. IE will be equal to IC by alpha. Okay, we are finding the voltage gain. So here we are V naught we have in terms of IC. Therefore, VI also we should get in terms of IC. So if you want to get VI in terms of IC, you have to substitute for IE. IE will be IC by alpha. VI will be equal to IE will be equal to IC by alpha. Substitute here IC by alpha into RE. IC by alpha into RE. Okay, that is VI. Now, once we know VI naught and VI equation, substitute in the gain equation. AB is equal to V naught by VI. That is IC RC. That is V naught divided by VI is IC small RE by alpha. Now here ICRC into alpha divided by ICRE. IC and IC will cancel. Therefore, AV will be equal to RC alpha divided by small RE. Okay. AV is equal to RC alpha divided by RE, small RE. Okay. Now we know that alpha value is approximately equal to 1. The current gain for the common base configuration, alpha value is approximately 1. Therefore, AB will be equal to, if you substitute alpha equal to 1, RC by RE. RC by RE. This is the equation of the gain for the common base configuration. Next, let us find the current gain equation. Since RE, small RE is very, very less than capital RE, we can take here, if we look into the RE model, small RE is very, very less than capital RE, or capital RE is very, very larger than small RE. So as capital RE is very, very high, the current flowing through capital RE is very less. It is negligible, and hence it can be neglected. Okay, so whatever is the input current that flows into the small RE, that is II is equal to IE. II is equal to IE. So we are using the equation IE is equal to approximately II, or II is approximately equal to IE. Now what is I naught? I naught is minus IC. Just now we saw I naught and IC are opposite in directions. Therefore, I naught is equal to minus IC. IC is alpha times IE. Right? IC is alpha into IE. Therefore, this will be minus alpha into IE. What is current gain equation, students? It is ratio of output current to input current. Therefore, first find I naught equation for I naught, then equation for input current II. Substitute in the current gain equation I naught by II. That is minus alpha IE. That is I naught. Then II is IE. IE and IE will cancel. That will be minus alpha. As alpha is approximately equal to 1, therefore current gain AI will be equal to minus 1. Okay, so equation for AI is minus 1, or it is minus alpha for the common base configuration. Now what is the phase relationship here? Let us see the gain equation. It is plus RC by RE, plus capital RC by small RE. That is, it is positive. It means output voltage and input voltage are in phase with each other. Input voltage VI and output voltage V0 are in phase with each other. Okay, so these are the equations for the common base configuration. What are the main equations? Let me quickly highlight the equations. Input impedance Zi, equation is small re. Zi is a small re for common base configuration. Then output impedance Z0 equation. Output impedance Z0 equation for common base configuration, it is RC, capital RC. Then voltage gain equation AV for common base configuration, it is RC alpha by RE. AV is RC alpha by RE. If alpha is approximately equal to 1, therefore AV will be equal to capital RC by small RE. But this is the main equation. Whenever you are solving the numerical, you have to consider the main equation. That is AV is equal to RC alpha by RE. Main equations have to be considered when solving the numericals. Then current gain equation is given by AI is equal to minus alpha. If as alpha is approximately equal to 1, therefore AI will be minus 1 approximately. But main equation is AI is equal to minus alpha. Okay. So this is about the common base configuration. We found the equations for voltage gain, input impedance, output impedance, current gain for the common base configuration using the AC equivalent RE model. Next question, students, that is question number 11. Explain with need diagram emitter follower configuration. Explain with need diagram emitter follower configuration. Next question is on emitter follower configuration. Justify how voltage gain is approximately equal to unity. So next question, question number 11. So we are considering the emitter follower configuration. Next question, emitter follower configuration. So for the emitter follower configuration, explain need circuit diagram emitter follower configuration and justify how the voltage gain is unity for the emitter follower configuration. So you have to prove that the voltage gain is 1 or output voltage equal to input voltage for the emitter follower configuration. So this is the emitter follower configuration circuit. So here input voltage is Vi, which is applied to the base terminal. Output voltage is taken from the emitter terminal. Note that output voltage is taken from the emitter terminal in emitter follower configuration. RB resistance, base resistance is present. Collector resistance is not present in emitter follower. Then emitter resistance is present, which is connected to ground from the emitter. Okay, from the emitter terminal it is connected to ground. Right? Input impedance Zi, output impedance is Z0. Then VCC is applied here to the junction of this RB1 end and the collector terminals. Okay. Now here in this emitter follower configuration, let us draw the AC equivalent circuit. So how to draw the AC equivalent circuit? AC equivalent circuit is done by making VCC equal to 0 and replacing the capacitors by short circuit. Correct? For DC analysis in module 1, the capacitors are replaced by open circuit, whereas in AC analysis second module, the capacitors are replaced by short circuit. Okay, and as it is AC analysis, we have to make the DC voltages 0. So make VCC equal to 0 here. Make VCC equal to 0. So if you make VCC equal to 0 and capacitors are short circuit, the circuit will be used like this. This is RB. It is connected between base terminal to ground. VCC is 0 here. DC voltage we are making 0. It is connected between base terminal to ground. That is what we are drawing here. RB is connected between base terminal to ground. Then we have the emitter terminal. Emitter terminal, we have the resistance RE connected from emitter terminal to ground. That is, we are drawing the same as it is. Emitter terminal, there is a resistance RE connected from emitter terminal to ground. Then where we are taking the output across RE. Across the emitter resistance RE, we are taking the output here. Across the emitter resistance RE, output is taken in the emitter follower configuration. That is V0 here across capital RE. Then what about collector terminal? Collector terminal is grounded because this VCC is 0 here. As VCC is 0, collector terminal is connected to ground. So make VCC and this collector terminal to connect to ground. If we make this collector terminal to connect to ground here, this collector terminal or this collector terminal, it is common to both input section and the output sections. Is it not? This collector terminal is common to both input section and the output portion. Okay, so as the collector terminal is common to both input portion and the output portion of the circuit, the emitter follower configuration is also called as common collector configuration. The emitter follower configuration is also called as common collector configuration. Remember, in examination they may ask, explain with neat circuit diagram common collector configuration and justify how voltage gain is approximately equal to unity. Or they may ask, explain with neat circuit diagram emitter follower configuration and justify how voltage gain is approximately equal to unity. Okay, they may ask in either ways. Remember, emitter follower configuration is also called as common collector configuration. So they may ask either as emitter follower configuration to derive its performance parameters, or instead of asking as emitter follower, they may ask it as common collector configuration and derive the performance parameters. Okay, so both are one and the same. Emitter follower circuit is called as common collector configuration, or common collector configuration is nothing but the emitter follower configuration. Remember, the collector terminal is common to input and output. Configuration is common collector. Let us write the equation for input voltage Vi. Input voltage Vi here. This is Vi. It is VBE plus V naught. Correct? It is across voltage, cross in parallel. Therefore, Vi will be equal to VBE plus V naught. Vi will be equal to VBE plus V naught. That is what is written here. Vi is equal to VBE plus V naught according to the KVL. Now, VBE is small compared to V naught. The VBE, it is 0.7 or 0.3 or 0.2, is approximately lesser, is comparatively lesser than V naught. Therefore, we are neglecting this VBE. We are neglecting this VBE. Therefore, if you neglect this VBE, Vi will be equal to V naught approximately, or V naught will be approximately equal to Vi. So what it indicates here, students, the output voltage is equal to input voltage in emitter follower configuration. So what is the meaning of output voltage at emitter follows the input voltage at base terminal? It means that the output voltage at emitter terminal is equal to input voltage at the base terminal. Remember. So the meaning of the output voltage follows the input voltage. It means that the output voltage is equal to input voltage. That is the meaning of output voltage follows the input voltage. So that is why the name given to this circuit is emitter follower, because the output voltage at the emitter follows the input voltage at the base terminal. Now from equation 1, what is the equation for gain? V naught by Vi, but V naught is equal to Vi, Vi and Vi will cancel. Therefore, gain will be approximately equal to 1. Gain will be approximately equal to 1. Thus, for emitter follower, voltage gain is approximately unity. It is equal to 1. Okay, we have justified that for emitter follower, the voltage gain is approximately 1. Now, let us replace a transistor in the above circuit by its RE model. Again, we are not considering small R naught. That is output resistance. We are not considering for simplicity purpose. Let us draw the RE model. If we draw the RE model of the emitter follower configuration, here we have the RB resistance between base terminal to ground. So it is as it is. RB resistance between base terminal to ground. Okay. Input voltage Vi is applied across this. Input current is II. Input impedance is Zi. Then at base terminal, the PN diode, the PN junction. So this is nothing but it is equivalent to AC resistance of the diode, that is RE, and it is modified to beta RE, right? This will become beta RE, emitter base junction. Okay. So this is beta RE here. Then we have at the emitter here, the resistance RE. RE resistance is there, correct? RE resistance is there here. So this RE resistance we are connecting from emitter to ground. Emitter to ground. It is connected between emitter to ground. RE resistance, this one, capital R. Fine. Then we have the collector current. IC is equal to beta into IB. It is common collector configuration. IC will be beta into IB. Let us see the direction of the collector current. So it is flowing. We look into the circuit here. So the direction of the collector current I is equal to IB plus IC. I is equal to IB plus IC. So yes. Therefore, collector current is flowing into the emitter terminal. It is beta into IB. Beta into IB. Output is taken across capital RE, emitter resistance. Right? IE is this. It is flowing in the downward direction. I naught according to the convention of the two-port network. I naught according to the convention of the two-port network. We are considering it as flowing into the circuit. I naught. Okay. Then output voltage is V naught. And output impedance is Z naught. Now, let us find the performance parameters. I am explaining that also. Applying KVL to the input circuit, we have Vi is equal to IB into beta RE plus IE RE. Vi is given by across voltage, that is IB into beta RE plus IE into RE according to the KVL. IB beta RE plus IE RE. Now, if you want to express this, if you want to find the input impedance, how you have to find, students? You have to express the current IE in terms of IB. Okay, IE will be 1 plus beta into IB. Remember, whenever you are finding the input impedance, after you write the KVL equation, substitute for the emitter current. How you have to substitute for the emitter current? Substitute the equation IE is equal to 1 plus beta into IB. So if you substitute this, IE is equal to 1 plus beta into IB, For any circuit, if whenever you are taking, when you are finding the input impedance, you have to substitute the equation I is equal to 1 plus beta into IB into the KVL equation. So if you substitute here, what we get, VI is equal to IB beta RE plus 1 plus beta into IB RE, IB RE. Okay. Now what is ZB? ZB is equal to VI by IB. ZB is VI across voltage divided by IB. Substitute now. VI is IB into beta RE. IB is common. Beta RE plus 1 plus beta into capital RE. That divided by IB. IB and IB cancels. We get beta RE plus 1 plus beta into capital RE. Take it as first equation. ZI is VI by II. ZI is VI by II. That will be RB parallel ZB. This RB parallel ZB. Okay. Now 1 plus beta is approximately beta. So equation 1 becomes, this equation 1 becomes here beta RE plus beta small RE plus beta capital RE, right? So take beta common, it will be RE small RE plus capital RE. So if you are taking beta common, small RE into beta into small RE plus capital RE. Now small RE plus capital RE is approximately equal to capital RE, because the value of capital RE is very, very larger than small RE. Therefore ZB will become beta into capital RE. So this is ZB equation. Next, output impedance Z0. Consider ZB is equal to VI by IB. What is ZB? ZB is the input voltage divided by base current IB. VI by IB. Arrange for IB. IB will be equal to VI by ZB. Now use the equation I is equal to 1 plus beta into IB. I is equal to 1 plus beta into IB. Therefore, IB will be equal to IE divided by 1 plus beta. So here also we have written the equation for IB, that is VI by ZB. Here also we got the equation for IB, that is IE by 1 plus beta. Both are same, equate them. I divided by 1 plus beta is equal to VI by ZB, or IE is equal to 1 plus beta into VI divided by ZB. Now substitute for ZB from equation 1, main equation, ZB. So that is beta into small RE plus 1 plus beta into capital RE. Substitute here the main equation, remember. So if you substitute the main equation, then we get 1 plus beta into VI divided by ZB is beta small RE plus 1 plus beta into capital RE. Now we know that 1 plus beta is approximately equal to beta, because beta is larger than 1. Therefore, this IE equation will be beta VI divided by beta small RE plus beta capital RE. So beta RE plus 1 plus beta capital RE will become, beta is common, small RE into small RE plus capital RE. So if we use these relations in equation 5, we have IE is equal to this one, beta VI divided by beta common into small RE plus capital RE. Beta common into RE small RE plus capital RE. Beta and beta cancels. We get VI is equal to IE into small RE plus capital RE. Now this is equal to IE small RE plus IE into capital RE. This is nothing but the KVL equation, and it is represented like this. So it is KVL equation. VI is IE RE, IE into small RE plus IE into capital RE. What is IE into capital RE? It is V0. Correct? IE into capital RE is the output voltage across emitter resistance, capital RE. So it is output here, V0. Okay. Now if you want to find Z0, right? So to find Z0, we have to make VI equal to 0. So before making VI equal to 0, we have to perform these analysis. We have to perform this analysis for the finding the output impedance. Okay. So after doing this analysis, then we have to make VI equal to 0. So once we make VI equal to 0, turn off the active sources. Okay. So what will be there here? If you make VI equal to 0, it is a short circuit. So it will be RE parallel capital RE. Okay. So it will be Z0 is small RE capital, small RE parallel capital RE, that is small RE into capital RE divided by small RE plus capital RE. Small RE plus capital RE is approximately equal to capital RE. Therefore, we get Z0 is equal to small R into capital RE divided by capital RE. Capital RE cancels. We get small RE as Z0. So this is Z0 is approximately small RE. Next, voltage gain equation. If you want to find out voltage gain equation, apply the voltage division rule to the circuit, whatever we got just now. That is V0 will be equal to, V0 is voltage across capital RE. That is main voltage VI into resistance of the same branch, that is capital RE, divided by sum of the resistances, that is small RE plus capital RE. Is V0 is VI into capital RE divided by small RE plus capital RE. Voltage division rule. Now rearrange the terms for V0 by VI. That will be capital R divided by small r plus capital R. As capital R is very larger than small re, therefore capital R plus small re will be approximately capital R. Okay, therefore gain will be V naught by Vi, that is capital R divided by capital Re. These two will cancel, that will be approximately 1. That means V naught is approximately equal to Vi. V naught is approximately equal to Vi. Therefore, we say that output voltage follows the input voltage. It means that output voltage is equal to input voltage. Next is current gain equation. V naught is I into capital Re. We know that output voltage is I, that is emitter current into emitter resistance. So we know that I is minus I naught because both are opposite in direction. We see the figure here. I and I naught both are opposite in direction. I and I naught both are opposite in direction. So therefore what we get here, I is equal to minus I naught. Substitute that. Therefore I naught will be minus V naught by Re. I naught will be minus V naught by Re. II is Vi by Zi. We know this. Now substitute these two in current gain equation. I naught by II, that will be minus V naught by Re divided by Vi by Zi. That will be V naught by Vi minus V naught by Vi into Zi by Re. That is V naught by Vi is minus AV gain equation. It is minus AV into Zi divided by Re. Now gain equation is 1. It is plus 1. Okay. Or it is plus capital R divided by small r plus capital R. It is positive. It indicates that the output and input are in phase with each other. Okay. This is question number 11. Next, coming to question number 12. Derive expression for, so you all understood here. What are the equations for the emitter follower configuration then? The equations are the equations. The first one is performance parameter input impedance Zi is RB parallel ZB. ZB is beta Re. Okay, or ZB is main equation beta into small r plus capital Re. Output impedance Z0, it is given by Z0 is equal to, what is the equation for Z0? It is small re parallel capital Re, or it is approximately equal to small re. Okay. Then voltage gain equation, it is AV is equal to V naught by Vi, that is capital R divided by small re plus capital Re. And this AV will be approximately equal to 1. Main equation is AV is capital R divided by small re plus capital Re. Then current gain equation, it is minus AV into Zi divided by capital Re. Okay. So memorize these equations and accordingly you have to solve the numericals and also derive the equations, that is performance parameters. Next is question number 12. Derive expression for AV, AI, Zi, Z0 of voltage divider bias configuration. So next is for the voltage divider bias configuration. Okay, this is the circuit. Common emitter. First we have to take up the voltage divider bias, that is this circuit. Common emitter configuration with voltage divider bias. Okay, so this is our voltage divider bias circuit. So for this voltage divider bias circuit, we are supposed to find performance parameters, that is voltage gain AV, current gain AI, input impedance Zi, output impedance Z0, right, using the RE model. Okay, this is our voltage divider bias circuit. R1 and R2 is there. Then we have RC, collector resistance, emitter resistance, capital RE. Okay, input is applied to the base terminal through C1 capacitor. Output is taken from C collector terminal through the coupling capacitor C2. There is a bypass capacitor CE. So this bypass capacitor is connected to ground the AC signals. Okay, if this bypass capacitor C is not present, then there will be negative feedback through RE to the input. There will be negative feedback. Output will be, so whatever this voltage at emitter terminal is there, that will be fed back to the base terminal, making the gain less, or the output voltage will be reduced. In order to avoid that, what is done is a bypass capacitor is connected CE, because it passes the AC signal. It passes the AC signal and blocks the DC signal, right? Blocks the DC signal, because for DC we know that it is open circuit, and for AC signal the capacitors are short circuit. That means the capacitors block the DC signal and they pass the AC signal. So this capacitor will bypass it to ground. Therefore, here we are connecting the bypass capacitor to make the AC signal to ground. Okay. Then output is taken from the collector terminal. It is voltage divider bias because The voltage divider rule is applied here between R1 and R2 in order to find the necessary voltage at the junction of R1 and R2. If we want to find the AC equivalent circuit or the RE model, we have to short circuit the capacitors and make the DC voltages 0. Now this is, we are performing small signal AC analysis to obtain the AC equivalent circuit first by making VCC equal to 0 and short circuiting the capacitors C1, C2 and CE. So if we short circuit C1, this C2 and this CE, then what we get? R1, R2, then collector resistance RC. Here VCC is made 0, right? Emitter resistance R is connected to ground. Now these are the observations. R1 is in between base and ground. This R1 appears from base terminal to ground. R2 is also between base terminal to ground. R1 and R2 are in parallel. R1 and R2 are in parallel. Then emitter resistance RE is connected between emitter terminal to ground. Collector resistance RC is connected between collector terminal to ground. These are the observations. Now RE is in parallel with CE, this short circuit. Short circuit means what is the resistance, students? Whether it is infinity or 0 for short circuit, it is 0, correct? So therefore RE is parallel with 0. RE into 0 divided by RE plus 0. That will be 0. Therefore this will be short circuit here. This will be short circuit. RE resistance will be simply a short circuit because RE comes in parallel with 0 ohms. It's a short circuit here. Fine. So RE parallel 0 ohms is 0 ohm. It is a short circuit. Therefore, the equivalent circuit will be, we have only R1 connected between base to ground, R2 between base to ground, then RC is connected between collector to ground. There is no RE resistance present because it's a short circuit, right? It's a short circuit. Just emitter terminal is connected to ground. We have ZI, Z0, VI, input current II, and output voltage V0. Emitter terminal is common to input and output circuit. It is much clear from this AC equivalent circuit. Emitter terminal is common to input portion and output portion of the circuits, and hence it is common emitter configuration. Voltage divider bias with common emitter configuration, or common emitter voltage divider bias configuration. Now R dash is R1 parallel R2. R dash is, these two are in parallel, R1 parallel R2. Now this circuit is same as the fixed bias configuration. Common emitter configuration with voltage divider bias is same as the common emitter configuration with fixed bias. Because in common emitter configuration with fixed bias, this RB is there. Here RB is there between base terminal to ground. Here we are having R1 and R2. So RB is nothing but it is similar to R1 parallel R2. In the equations of the common emitter configuration with fixed bias, if we replace RB by R1 parallel R2, that gives all the equations for the common emitter configuration with voltage divider bias. Remember, in the equations for the common emitter configuration fixed bias, wherever it is RB, replace it by R1 parallel R2. That will give the all the equations of the common emitter configuration with voltage divider bias. Okay. So this is with voltage divider bias, whatever we have drawn. What are the equations then? Zi will be Vi by Ii. It is R dash parallel beta R. This is the equation for the fixed bias configuration. I will come to that. Then Z0 is R naught parallel RC. Remember the equations. Small R naught parallel capital RC. Then gain equation AV is minus R naught parallel capital RC by small RE. AV is equal to minus R naught parallel capital RC divided by small RE. Then current gain equation is minus AV into Zi by capital RC. Current gain is minus AV into Zi by capital RC. If R0 is greater than or equal to 10 times RC, this R0 is greater than or equal to 10 times RC, substitute here 10 times RC parallel with capital RC. So the parallel combination of large resistance with small resistance will be small resistance only. Therefore, Z0 is approximately RC. Similarly, here gain equation minus R0 parallel RC. Substitute R0 is 10 times RC. 10 times RC parallel with RC, that will be smaller value. So it is AV is equal to simply minus capital RC by small RE. Gain is negative. It indicates that the output voltage and input voltage are 180° out of phase with respect to each other. So these are the various equations for common emitter configuration with voltage divider bias, or it is simply called as voltage divider bias. Okay. Now let us look at fixed bias configuration, which is similar to the common emitter voltage divider bias, but we have to replace RB by R1 parallel. So this is common emitter fixed bias configuration. Common emitter fixed bias configuration. In fixed bias configuration, we have RB resistance at base terminal, RC resistance at collector terminal. There is no emitter resistance. Emitter terminal is connected to ground. Okay. So first you all have to remember the basic circuit. Start from the basic circuit, then draw the AC equivalent circuit, then later draw the RE model, and from the RE model you have to derive the performance parameters. You know by now how to derive the performance parameters. Okay, which equations you have to substitute. Okay, how you have to find the output impedance, that is you have to turn off the active sources, that you know all those things, how to find the performance parameters. So this is Zi, then we have Z0, input current II. Okay, then this is VBE, VCE, the base current IB, collector current IC. This is the AC equivalent circuit. We have VCC will be made equal to 0. So RB is present in between base terminal to ground. RB is present between base terminal to ground, and RC is present between collector terminal to ground. Emitter is grounded. Short circuit the capacitors for AC analysis. Base terminal is the base resistance is present between base terminal to ground. Then collector resistance is present between collector terminal to ground. Emitter is grounded. This is the AC equivalent circuit. From AC equivalent circuit, we are drawing the RE model. So what is the RE model? The base resistance is same between base terminal to ground. Then we have this PN forward bias junction. It is similar to the forward bias diode. Forward bias diode. It is replaced by its AC resistance, that is small RE. Further, this is modified into beta RE. Beta into small R. It is beta RE here. Then here the collector current is IC is equal to beta into IB. It is common emitter configuration. So it is IC is beta IB, which is flowing into the collector terminal. I is equal to IB plus IC. It is flowing into the collector terminal, beta into IB in the downward direction. We have considered the output resistance R0. Then that comes in parallel with the resistance RC, which is connected between collector terminal to ground. Collector terminal to ground. Okay. Now Zi is Vi by II. Zi is Vi by II. Now we know that Zi is RB parallel beta RE. If you look into this portion of the input, Zi will be RB parallel with beta RE. Both are in parallel here, connected across. Therefore, Zi is RB parallel beta RE for the common emitter fixed bias configuration. Now let us find output impedance. If you want to find output impedance, we have to make Vi equal to 0. Remember, whenever you are finding output impedance for the AC analysis in module 2, you have to make the input voltage 0. You have to turn off the active sources. So once we make Vi equal to 0 in this RE model, II will be 0, IB will also be 0. If IB is 0, beta IB will also be 0. So in beta IB is 0, it is open circuit here. So only resistance present are R0 and RC. It is open circuit here, the resistance present are R0 and RC. So what will be Z0 students? If you look from this side, it is R0 parallel capital RC. Z0 will be small R0 parallel capital RC. Now, if you want to find voltage gain, we have to consider the output equivalent circuit at the output side. It is beta AB, R0 and RC. Consider only the output portion. Find the voltage gain. Beta AB, small R0, output resistance, then capital RC, collector resistance. This is beta AB, it is as it is. Small R0 parallel capital RC is output impedance. Just now we wrote the equation. Z0 is small R0 parallel capital RC. Write it. Z0 here. Z0 here. Okay. Then V0 is minus beta AB into Z0. Equation for V0 is minus beta AB. Here it is minus because it is moving into the negative terminal, ground terminal. Okay, so it is minus beta AB into Z0. Okay, that is minus beta AB. Z0 is R0 parallel RC. Now from the input circuit, that is AC equivalent circuit with the RE model, Vi is given by, from the RE model, IB into beta RE. Yes or no? Vi is IB into beta RE. Correct? Because it is in parallel, Vi is IB into beta RE. Therefore, substitute this V0 and Vi in the gain equation. V0 by Vi that will be minus beta IB into R naught parallel RC divided by IB beta RE. IB beta cancels. We get minus R naught parallel RC divided by RE. Minus small R naught parallel capital RC divided by small RE. Now here we have to apply two conditions for the fixed bias configuration. There are two conditions. One is RB is greater than or equal to 10 times beta RE. So if RB is greater than or equal to 10 times beta RE, RB parallel beta RE will be how much? RB is 10 times beta RE, the parallel with beta RE. Large resistance parallel with small resistance will be small resistance only. Therefore, we get beta RE. Therefore, what will be the equations 2 then? In equation 2, what we have? RB parallel beta RE, that is 10 times beta RE parallel with beta RE, that will be simply beta RE equal to ZI. ZI will be simply beta RE under the condition RB is greater than or equal to 10 times beta RE, remember. Similarly, for the output, let us apply the condition resistance at the output, that is output resistance greater than or equal to 10 times RC. Under this condition, what will be R naught parallel RC? That is 10 times RC parallel RC. So it will be smaller value, that is capital RC only. 10 times RC parallel capital RC, that will be smaller value, that is capital RC. Therefore, equation 3, you see equation 3, R naught parallel RC, that is 10 times RC parallel RC. Therefore, it will be simply equal to capital RC, that is Z naught. Z naught will be capital RC. Similarly, gain equation AV will be minus R naught parallel RC by RE, that is minus R naught is how much? Minus R naught, this 10 times RC parallel RC, that will be RC only. Therefore, AV will be minus capital RC by small RE, minus capital RC by small R. Okay. Last one, current gain equation. It is a ratio of output current to input current. Let us find output current equation and input current equation. V naught is minus I naught into RC. See here, V naught is minus I naught into RC. This one here, V naught is minus I naught into RC. Okay, at the output terminals, minus I naught into RC. Because current entering positive, current leaving negative, positive to negative minus I naught RC, then positive to negative minus V naught equal to 0, or V naught will be equal to minus I naught into RC. Applying KVL to the output loop. Therefore, I naught will be minus V naught by RC. II is VI by ZI. Use these relations in equation 10, that is current gain equation. I naught is minus V naught by RC, that divided by VI upon ZI. Therefore, this will be minus V naught by RC into ZI upon VI. That is minus V naught by VI into ZI by RC. V naught by VI is what, students? It is gain, voltage gain. Yes or no? That is AI will be minus AV into ZI divided by RC. So, if we substitute equation 9 and 7 for AV and ZI, if we substitute for AV and ZI, what is AV? AV is equation 9 minus RC by RE. 7 is here, that is ZI is beta RE. Substitute this in equation for AI. Therefore, AI will become minus 1 upon RC, that is this minus 1 upon RC. AV is AV equation minus RC by RE. Then ZI equation is beta RE into beta RE. What will cancel here? RC cancels, RE cancels, minus into minus is plus. Therefore, current gain will be approximately beta. Okay. So, what are the equations here, students? Then, as the gain is negative, it is minus RC by RE. Just now we saw that. Here, AV is minus RC by RE. That means output and input are 180° out of phase with respect to each other. Right. What are the equations here, students? Let us quickly recollect the equations for fixed bias configuration. So this is a fixed bias configuration, common emitter fixed bias configuration, or simply fixed bias configuration. AC equivalent circuit RE model. Then ZI is RB parallel beta RE, mean equation. RB parallel beta RE. Beta's RB parallel beta small RE. So wherever it is capital RE and small RE, just try to remember correctly whether it is capital RE or small RE. Okay. Instead of a capital R, if you write small r, and instead of small r, if you write capital R, the equations will go wrong, and whenever you are solving the numericals, there also the answers will be coming wrong. So we have to see wherever it is capital R and wherever it is small r, and accordingly we have to use the equations. An equation for Z naught is small r naught parallel capital RC, small r naught parallel capital RC. Main equation. Then voltage gain main equation, that is minus R naught, small r naught parallel capital RC, that divided by small re. Okay. Gain equation, main one. then that will be further simplified to AV is minus capital RC by small re. Then current gain main equation for current gain is minus AV into ZR divided by capital RC minus AV voltage gain into input impedance divided by capital RC collector resistance. Okay. So that will be further simplified to current gain is approximately equal to beta. But the main equation is this. So we have to use the main equations when solving the numericals. A will be equal to minus AV into ZR divided by capital RC. These equations have to be used. Then AI will be further simplified to beta, approximately equal to beta. Okay. So these are the equations, students. In the next class, I will be taking the next 4 questions are remaining. Okay. In the assignment, those I will take up in the next class. Hope all of you have understood. Right. If there are any questions, you can ask. Any questions here, students? Any questions here? Yes, please. Ankita, any questions? Ankita?
No, sir, no questions.
Okay. Harshgowda? Harshgowda? Mohammed? Mohammed? Rutik Chopde? Rutik Chopde? Sai Prakash?
Yes, sir.
Any questions, Sai Prakash?
No, sir. No question.
Okay. Samir Ahmed? Samir Ahmed? Any problem in understanding? Sania? Sania? Sankal?
No,
Sankal?
sir.
Any
No
problem in
problem.
understanding, Sankal? Clear, right?
No, sir. No problem.
Okay,
No,
fine.
sir. Clear, sir.
Yes. Okay, good. Shiraj? Shiraj? Shraddha? Shraddha?
No, sir.
Clear, right, Shraddha? Okay.
Yes, sir.
Shubham? Fine. Shubham? Shubham?
Yes, sir.
Was it clear today's assignment questions, Shubham?
Yes, sir.
Okay. Tejas? Tejas? Manjunath? Manjunath? Okay. So the next 4 questions are remaining. That I will take up in tomorrow's class. Right. Today I will not be taking any class, but tomorrow I will engage the class. Today afternoon I will not be taking the class. Tomorrow I will take half an hour session. Okay, from 2:30 to 3, where I will be covering up the 4 questions. Okay, that I will take up tomorrow. So please be present for the class. Okay, thank you.